Alright, starting off with chapter 7, section 1, we're going to be talking about the distributive property. You guys may or may not have used this in the past. So our distributive property is when we multiply a sum or difference by a number, and then we, in doing that, multiply each term inside the parentheses by the number outside of the parentheses. So as you can see here, we have an A on the outside and a B plus C on the inside, or conversely, subtraction. We take our A times each number on the inside to rewrite it as A times B plus A times C. If we did it with numbers, you see we would have 5 times 6 and then plus 5 times 7, and then we would be able to evaluate from there. So practicing, use the distributive property to write each expression as an equivalent numeric expression, then evaluate the expression. So we are going to distribute our 5 to each number inside and rewrite it. So we have 5 times 12 plus 5 times 4. So there's our equivalent expression. Now evaluating, 5 plus 12 is 60, plus 5 times 4 is 20, and then 60 plus 20 gives us a final answer of 80. Okay, if you look at part B, we have the quantity of 20 minus 3 times 8.2. So we're distributing again, we're just distributing backwards. So rewriting, we have 8.2 times 20 minus 8.2 times 3. So again, there's your equivalent expression. And if we calculate that out, we have 8.2 times 20 is 164 minus 8.2 times 3 is 24.6, and then we're subtracting this time, gives us a final answer of 137.4, or 137 and 4/10. Okay, there's our distributive property using just numbers. So if we use that idea for mental math, on a school visit to Washington, D.C., the Charlie and his class visited the Smithsonian National Air and Space Museum. Tickets to the IMAX movie cost $8.99. Find the total cost for 20 students to see the IMAX movie. We could use the distributive property in mental math to find the total cost of the movie. As you see there, we have $8.99. That's not exactly something that would be easy to do mentally. So a different way to think of this would be $9 minus 1 cent. And then we're doing that 20 times because there's 20 students. So then we use our distributive property. 20 times $9 would be 180, minus 20 times 1 cent would be 20 cents. So now if I take 20 cents away from $180, that leaves us with $179.80, which if we double check, we are correct, $179.80. So there's a way that you could use your mental math with your distribution to do something where, again, $8.99 is not exactly something easy to calculate in your mind, but $9.01 is easy to calculate, and then just subtract them. Okay, now, looking at the distributive property with expressions involving variables, so our algebraic expressions. If I have 4 times the quantity of x plus 5, we're going to go ahead and distribute. So 4 times x is 4x plus 4 times 5 is 20. Now you cannot combine these two. This term has an x, this term does not. At next lesson we're going to talk about what we can and cannot combine as far as like terms go. But just know your answer for now is 4x plus 20. If we look at part B, same thing, we just have our distribution at the back. 6 times y is 6y. Notice, guys, the number always comes before the variable. plus 6 times 10 is 60. Keep going. 3 times m minus 4 leaves us with 3m minus 12. And if we take a negative 9.5, working with negatives this time, times n minus 7, so a negative 9.5 times a positive n gives us a negative 9.5n. Then a negative times a negative, think of that as a negative 7. Well, I know two negatives make a positive, so it would be plus 66.5. And the last one, dealing with some fractions here. 2/3 times d minus 3 leaves us with 2/3 d minus 2/3 times 3 would be 2, so 2/3 d minus 2. Okay, so there's some examples using the distributive property with an algebraic expression. Again, notice we do not end up with just one answer. When you have a variable and a term without a variable, you cannot combine them when we're adding and subtracting. Okay, so you've got 2 with the now you try. Use your distributive property to write each expression as an equivalent algebraic expression. So 2 of them there for you to try. All right, guys, that's the end of lesson 1.